It was the 1940s. The world was at war. While nations battled with bombs and bullets, a quieter war was brewing. One fought with ideas, mathematics, and a deep desire to understand the human mind. In the midst of this chaos stood a man of unusual brilliance, Warren McCulloch, a neurophysiologist, philosopher, and poet. McCulloch wasn't building weapons. He was trying to decode the most powerful machine of all time, the human brain. McCulloch's academic path was as multidisciplinary as his mind. He studied at Yale, where he earned a degree in philosophy and psychology. Later, he went on to Columbia University to pursue medicine. But unlike most medical students, his interest wasn't in curing the body. It was in understanding the mind. By the 1930s, McCulloch was already asking big questions. How does the brain generate thought? Can reasoning, memory, and perception be explained in terms of logic and circuits? Can a machine ever think? His background in both biology and logic gave him a unique perspective, one that most others couldn't see. He believed that mental processes, no matter how mysterious, could be modeled mathematically. And during the height of World War II, he began collaborating with an unlikely partner, a teenage genius named Walter Pitts. Together, they would build something that had never existed before. A logical model of the brain. A machine-like abstraction of neurons. A system that could, in theory, think. In the spring of 1943, two minds from vastly different worlds, Warren McCulloch, a 45-year-old neurophysiologist, and Walter Pitts, a 20-year-old mathematical prodigy, published a paper that would change everything we know about intelligence, thought, and machines. Their goal was simple and impossibly ambitious: to understand how the brain processes thought. Not emotionally, not spiritually, but mathematically. They believed that if neurons obeyed physical laws, then thought itself could be reduced to logic. They proposed that neurons could be represented as binary switches, either firing on or silent off, just like the ones and zeros that power modern computers. This led to the first model of an artificial neuron, the McCulloch-Pitts neuron. It accepted multiple binary inputs. If the total sum of weighted inputs exceeded a certain threshold, the neuron fired. Otherwise, it remained silent. You might be thinking, okay, so what? Well, here's the kicker. They showed that networks of these artificial neurons could perform any logical operation, and or not, you name it. This meant that mental processes like decision-making, perception, even memory, could be mimicked with nothing but math and wires. The paper didn't just propose a model. It proposed a philosophy that the mind is computable, that the biological brain and digital circuits might not be so different after all. It was the first time anyone had formally linked neuroscience, logic, and computation in a single framework. This was the seed from which artificial intelligence would eventually grow.